Hello everyone. Today we will see some practice questions in the chapter Chemical Bonding and Molecular Structure. So let's start. First, the disclaimer slide, which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So this is our index slides and we will see some practice questions in this slides from question 1 to question number 13. So let's start from question number first. Which of the following statements is or are true? Options are HF is less polar than HBr. Absolutely pure water does not contain any ions. Chemical bond formation takes place when forces of attraction overcome the force of repulsion. In covalency, transference of electrons takes place. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. So a chemical bond is formed when the force of attraction are greater than the force of repulsion. Hence, option C is the correct answer. Moving on to our question number 2. Consider the Born-Haber cycle for the formation of ionic compound given below and identify the compound formed. So this is the reaction. First of all, the metal in solid form has delta H1 energy going to metal in gaseous form having delta H2 energy of this reaction is this conversion, and then going to an ion in gaseous state. Similarly, half of X2 going from gas going to the simpler atom, and then it is going to become an anion. And these all will combine together and form a Z compound. And the enthalpy of this reaction will be del H5. So the formation of ionic compound and what will be the compound formed. So options are M positive X negative, M positive X negative in solid, MX, M positive X negative in gaseous. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So the Born-Haber cycle takes place as follows given in this diagram or structure. So first we have a metal in solid, then it is converted to the gaseous, and then losing one electron, it converts to the cation. Similarly, half of X2 in the gaseous state converting to the simpler atom and then gaining an electron and becoming an X negative and anion. And on combining these two gaseous ions, it will become a solid ionic compound that is M positive and X negative. And the energy used in this reaction is lattice enthalpy, that is minus U. So the Z, that is the ionic compound formed, will be M positive X negative solid. Hence option B is the correct answer. Let's move on to the question number 3. What is the geometry of nitrogen atom in NH3, NCH3 whole thrice, and NSiCH3 whole thrice, CAS whole thrice molecules? First, trigonal planar, second, trigonal pyramidal, third, square planar. Choose the correct option. So you have options as second and first, third, second and first, second and third, first, third and second. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So in case of NH3 and NCH3 whole thrice, the structure will be trigonal pyramidal due to the lone pair bond pair repulsion. And here you can see NH3 and NCH3 whole thrice structure having one lone pair on the nitrogen atom, that is central metal atom, and they have the shape of trigonal pyramidal. While In case of NSiCH3 whole thrice, it is planar. So you can see here that this has a planar, that is trigonal planar structure. It is due to the fact that lone pair on nitrogen atom is transferred to the empty d orbitals of silicon, that is p pi d pi overlapping, and its Lewis base character is lost. Also, here the SiCH3 whole thrice molecule are 3, so it will be this. Hence, option A will be the correct answer, that is trigonal pyramidal and trigonal planar. Let's move to question number 4. O2 molecule is paramagnetic due to the presence of, options are 2 unpaired electrons in antibonding molecular orbital, 1 unpaired electron in antibonding molecular orbital, 2 unpaired electrons in bonding molecular orbital, 1 unpaired electron in bonding molecular orbital. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So we have O2 molecule which is having 16 electron in it. So, and we can arrange these 16 electron in the molecular orbital like in this way, and this is the orbital configuration of O2 molecule. And according to the molecular orbital theory, as there are 2 unpaired electron present in the antibonding molecular orbital, hence it is paramagnetic. You can see here that here there are 2 unpaired electron present in pi star 2px1 and pi star 2py1. So they are 1 1, that is singly unpaired electron present in the antibonding molecular orbital. Hence, the O2 molecule will be paramagnetic. Moving to question number 5. The BCl3 is a planar molecule, whereas NCl3 is pyramidal, because options are BCl bond is more polar than NCl bond. NCl bond is more covalent than BCl bond. Nitrogen atom is smaller than boron atom. BCl3 has no lone pair electrons, but NCl3 has one lone pair of electrons. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so correct option will be D option. So it is the structure of BCl3 molecule having no lone pair on the B, that is boron atom, and this is the structure of NCl3 having one lone pair on the nitrogen, that is central metal atom. Hence option D will be the correct option. Let's move on to the question number 6. H2, that is water, is dipolar, whereas BeF2 is not. It is because options are the electronegativity of fluorine is greater than that of oxygen. H2 involves hydrogen bonding, whereas BeF2 is angular discrete molecule. H2O is linear and BeF2 is angular. H2O is angular and BeF2 is linear. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number D. So the structure of H2 is angular, that is V shape, and has sp3 hybridization in it, and bond angle will be 104.5 degree, and its dipole moment value is positive or more than 0. So you can see here, this is the diagram of H2 molecule. This is the structure of H2 molecule having bond angle of 104.5 degree, and here the dipole moment is greater than 0, that is positive. And this is the structure of BeF2 having angular moment, having bond angle of 180 degree, and in BeF2 structure is linear due to the sp hybridization, and the dipole moment will be 0. Thus, due to the dipole moment is positive, H2 is dipolar, and due to dipole moment is 0, BeF2 is non-polar. Hence, option D will be the correct answer. Moving on to the next question, question number 7. In terms of polar character, which one of the following order is correct? Options are NH3 is least, then H2O, then HF, then H2S. Or H2S least, then NH3, then H2O, then HF. Or H2O least, then NH3, then H2S, then HF. Or HF least, then H2O, then NH3, or then H2S. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer will be option number B. So polarity is decided by the electronegativity difference between the two adjacent atoms. So the correct order of polarity will be the most in HF, then in H2O, then in NH3, and then in H2S. So the electronegative difference between the H and F, that is fluorine atom, is most. That is the highest in among these molecules. Hence, the polar character will be more in the HF molecule than the rest of the molecule. Hence, the order will be this. So, the option B is the correct answer. Moving on to next question, that is question number 8. What will be the lattice enthalpy of CaCl2 if the enthalpy of sublimation energy of calcium is 121 kilojoule per mole? Dissociation energy of Cl2 to Cl is 242.8 kilojoule per mole. Ionization energy calcium to Ca2 positive is 2422 kilojoule per mole. Electron gain enthalpy for chlorine to chlorine negative is minus 355 kilojoule per mole. And the del FH overall is minus 795 kilojoule per mole. Options are minus 3225.8 kilojoule per mole, minus 980.8 kilojoule per mole, minus 2870.8 kilojoule per mole, or minus 2628 kilojoule per mole. So these are the different energies given here for the reaction happening of CaCl2. And the options are given like this. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be C option. So we have given the sublimation energy of calcium is 121 kilojoule per mole, and the dissociation energy of Cl2 to Cl atom is 242.8 kilojoule per mole, and the ionization energy of calcium to calcium 2 positive is 2422 kilojoule per mole, and the electron gain enthalpy of chlorine to chlorine ion will be minus 355 kilojoule per mole, and the del F of CaCl2 is minus 795 kilojoule per mole. So the total del F, that is lattice enthalpy of CaCl2 molecule will be the sum of all these enthalpies given here or energies given here. So first sublimation energy of calcium, then dissociation energy of Cl2, then ionization energy of calcium 2 positive, then twice of electron gain enthalpy for the chlorine atom, and then the lattice enthalpy of CaCl2 molecule. So we put the given amounts in this equation, and this is the thing we have to find out. This is the variable. So the variable, the lattice enthalpy of CaCl2 is coming out as minus 2870.80 kilojoule per mole after solving this equation. Hence, the correct option will be option C. Moving on to next question, question number 9. Select the correct statements. Both lattice energy and hydration energy decrease with the increase in ionic size. Lattice energy can be calculated using Born-Haber cycle. If the anion is larger than the cation, the lattice energy will remain almost constant within a particular group. All of the above statements are correct. So we have to choose the correct statement. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer will be option D. So in the option A, both lattice energy and hydration energy decrease with the increasing ionic size due to the reduced electrostatic attractions in both solid state for lattice energy and in solution for hydration energy. So this is the correct answer. This is the correct statement. And B, according to the Born-Haber cycle, del H of formation will be the sublimation energy plus ionization energy plus dissociation energy plus electron affinity plus lattice energy. So we can find the lattice energy by using Born-Haber cycle. Hence, B option is also correct. Generally, while the lattice energy tends to decrease with increasing ionic size, if the anion is significantly larger than the cation, the lattice energy can remain relatively constant within a group. Hence, option C is also the correct statement. Thus, the correct answer will be D, that is, all the given statements are correct. Moving on to our next question, question number 10. The bond dissociation energy of BF bond in BF3 is 646 kilojoule per mole, whereas that of CF in CF4 is 515 kilojoule per mole. The correct reason for higher BF bond dissociation energy as compared to that of CF bond is: options are smaller size of B atom as compared to that of carbon atom, stronger sigma bond between B and F, that is boron and fluorine in BF3 as compared to that of carbon and fluorine in CF4, significant p-pi interaction between boron and fluorine in BF3, whereas there is no possibility of such interaction between carbon and fluorine in CF3. Lower degree of p-pi interaction between boron and fluorine in BF3 than that of between carbon and fluorine in CF4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So in the BF3 molecule, there is a significant p-pi interaction between unshared p orbital, that is empty orbital of boron, and lone pair of electrons in 2p orbital of fluorine. So you can see here in the BF3 molecule, there is a lone pair going to the boron empty p orbitals. It will become BF3 positive. Then the interchange of double bond will happen, that is the resonance effect, and the BF3 positive molecule will become the BF3 positive, and the double bond will change its position and resonance effect will happen. Hence, the p-pi interaction between unshared p orbital of boron and lone pair of electron on the fluorine atom cause this. So, option C will be the correct answer. Moving on to the next question, question number 11. If HX bond length is 2 angstrom and HX bond has dipole moment of 5.12 multiplied by 10 to the power minus 30 coulomb meter, the percentage of ionic characters in the molecule will be. Options are 10%, 16%, 18%, or 20%. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. Since dipole moment is equal to mu equals to Q cross D, and the mu calculated will be Q, that is 1.6 into 10 to the power minus 19 coulomb, and D, that is bond length, which is given as 2 multiplied by 10 to the power minus 10 meter. As it is given in angstrom, we will convert it into the meter. It is coming out as 3.2 multiplied by 10 to the power minus 29 coulomb meter. So percentage of ionic character will be equal to mu experimental upon mu calculated. So mu experimental we have given 5.12 multiplied by 10 to the power minus 30 coulomb meter, We can write it as 10 to the power minus 29 multiplied by 10 to the power minus 1 divided by mu calculated that we have calculated here, that is 3.2 multiplied by 10 to the power minus 29, and we are talking about percentage, so multiply by 100, and 10 to the power minus 29 will cancel out and it will come out as 16%. Hence option B will be the correct answer. Moving to the question number 12. The geometrical shape of XEF5 positive and XEF6 and XEFA2 negative respectively are. Options are trigonal bipyramidal, octahedral and square planar, square pyramidal, distorted octahedral and square antiprismatic, planar pentagonal, octahedral and square antiprismatic, square pyramidal, distorted octahedral and octahedral. We have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. So in XEF5 positive, we have 5 bond pair and 1 lone pair. So the shape associated with it is square pyramidal. In XEF6 molecule, we have 6 bond pair and 1 lone pair. So the shape will be distorted octahedral. And in the XEF82 negative, 8 bond pair and 1 lone pair will be present. So the shape will be square antiprismatic. Hence option B will be the correct answer. Moving on to our last and question number 13. Suppose the observed value of dipole moment of H2O molecule is 1.83 D. What will be the HOH bond angle in H2O molecule? So given bond moment of OH will be 1.5 D. So options are given here: 104 degree and 20 minutes, 105 degree, 105 degree 20 minutes, or 104 degree. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So as the dipole moment of H2O is the resultant of two vectors, that is OH bonds, therefore, if alpha is the angle between the two vectors, then this is the diagram, and this is the OH bond, this is the OH bond, this is the alpha or alpha angle between the two vectors, OH vector and this OH vector. So the dipole moment of H2O will coming out as mu OH whole square plus mu OH whole square plus 2 mu whole square OH cos alpha. So putting the values in it, we have the equation this, and then we can interchange the numerals from left hand side to right hand side, and we have cos alpha equals to minus 0.2476. Bond angle alpha equals to 104 degree 20 minutes we calculated from this, or cos 180 minus theta will be equal to minus cos theta, that is cos 180 minus alpha will be equal to 0.2476, minus will cancel out, and from this equation we find out the bond angle alpha exactly, that is 104 degree 20 minutes. Hence option A will be the correct answer. Thank you.